Tonight's notes are getting started in learning how to prove parallelograms in a coordinate plane. So basically, we're going to be able to construct proofs and use methods such as the distance formula, the slope formula, to decide whether a figure given points is actually a parallelogram. So it would be something like this. Let's say they give us that A is -7, 4, and B is 1, 2. C is 9, -8, and D is 1, -6. And the question might be, is this figure ABCD a parallelogram? Prove it by using the coordinate plane. So sure, we could draw a coordinate plane. We'd have that. We could see where the points are, we could figure it out. But the only way we're going to be able to prove it is by using one of 3 methods. And here are the methods below. All right, so I'm going to move down a little bit. So method 1 is this. Method 1. Method 1. There's 3 ways we could do this. We're going to start with the first method. The first method of proving that a figure is a parallelogram in the coordinate plane is to prove that both pairs of opposite sides are congruent. Because remember, if we look back at our notes, we talked about these 5 things. Opposite sides are congruent. If that both pairs of opposite sides are congruent, then that's enough to say that it's a parallelogram. So, first method is to prove that both pairs of opposite sides are congruent. Okay, so let's say I have my figure ABCD. Basically, it's saying that if AB is congruent to the opposite side DC, and AD is congruent to its opposite side BC, then this figure ABCD is a parallelogram. And we just write it as ABCD is a parallelogram. Okay, so that's the first method. We're going to prove that both pairs of opposite sides are congruent. Well, what would we use to prove that 2 sides of something are congruent? Well, congruency is talking about length, and if I have points on a graph, how do I find length? I'm going to use the distance formula. So use the distance formula. Okay, and in case we've forgotten it, the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. So there's the distance formula. All right. So that's the first method of proving a parallelogram in the coordinate plane. And these methods, like I said before, they're all coming from these properties of parallelograms. All right, so opposite sides are congruent. So another way is looking at the fact that the opposite sides are parallel. So method 2 is to prove that both pairs of opposite sides are parallel. All right, so if I have my ABCD, I want to prove that AB is parallel to DC. So if AB is parallel to DC, the opposite side, and AD is parallel to BC, then the figure is a parallelogram. So we want to prove that both pairs of opposite sides are parallel. Well, in the previous method, we wanted to prove that both sides are congruent, so we used the distance formula. What would we use to prove that lines are parallel? Well, when we look at lines that are parallel or perpendicular or anything about that, we're looking at their slope. So in this case, we're going to use the slope formula. Because we want parallel lines to have the same slope. So our slope formula is m equals y1 minus y2 over x1 minus x2. Or you could switch the ones and the twos, it doesn't matter. Awesome, all right, so those are two methods, and remember I told you there's three methods, so here's the last one. Our last method, method number 3. Okay. So method number 3 is kind of a combination of this stuff, okay? It deals with our parallel sides as well as our congruent sides. So here's method 3. We're going to prove one pair of opposite sides prove that just one pair of opposite sides is both congruent and parallel. One pair of opposite sides are congruent and parallel. So if we have our figure ABCD, it doesn't matter which pair we use. I'm going to use AD and BC. Okay, so I want to prove that AD and BC are congruent. So if AD is congruent to BC, and those sides are also parallel, so AD is parallel to BC, then the figure is a parallelogram. Because if we know that one pair of sides are the same length and they're also parallel, no matter what AB or DC are, if you just have those one pair of opposite sides, then it's going to be enough to prove that it's a parallelogram. So for this, if we're going to prove both congruence and equal slope to make them parallel, we're going to need both formulas. So we're going to use distance and slope formulas. Distance and slope formula. So now that we've gone over these three methods, let's look back at our original example. So they gave us these 4 points, A, B, C, D. So I definitely recommend plotting the points in a coordinate plane just roughly so that you can kind of see where the letters are aligned. So A is -7, 4, so it'd be somewhere around here. So that's A. B is 1, 2, so it might be somewhere here. C is 9, -8. So there, and then D is 1, -6, so here. Again, my picture is not perfect, but I just want to know, like, is AB a side or is it a diagonal? I just need to kind of know that, okay? So we are actually going to prove this by using the distance formula. So we're going to use the distance formula to see, for method number 1, that both pairs of opposite sides are congruent. So we're going to find the distance of AB. You're going to find that distance. We're going to find DC. Then we're also going to find AD and BC. So according to this method, if AB and DC are congruent and AD and BC are congruent, then it's a parallelogram. So let's go ahead and apply that distance formula to find it. So you're going to do the work on your own and pause the video and then come back and check your answers in just a moment when you're done with your work. So go ahead and pause the video now and find the distances for those. So check your work here. make sure that you've plugged in everything correctly to the distance formula. Your setup might look a tiny bit different, but we'll still end up with the same answers. So we found that A, B, and DC are both equal to the square root of 68. So those are congruent, which is what we want. Congruent, congruent. And then 164, 164 square root, those are both congruent, which is also what we want, congruent, congruent. So we've proven that both pairs of opposite sides are congruent, therefore ABCD is a parallelogram. So that's just a glimpse of how we're going to use the coordinate plane to prove that parallelograms are in fact actually parallelograms. All right, there's no questions tonight, just make sure you have all of these notes. I'll be checking the notes for your homework tomorrow. Have a great night.